Hello everyone, welcome to Think Global Education Services SAT Math class. Guys, this is the sixth video in the geometry series, and I will be ending the concept of geometry with this video. Now here we'll be discussing the last bit which was left, that is 3D geometry. So basically your 3D figures like your cubes, cuboids, your cylinders, your cones. So basic formulas that you need to be aware of in your SAT. Okay, so let's start the discussion with our 3D geometry. Now, the first formula here that we have to understand is a room is 10 by 12 by 15. I'm also sitting in a room, you are also sitting in a room. So what is the longest rod that can fit inside a room? For that, let's try to draw cuboid, because if you understand, a room is nothing but a cuboid. So if I try to draw a cuboid, something like this, so let me join the edges. So a cuboid basically looks like this. So I hope you are able to visualize this cuboid. So it's a cuboid. Now if I want to fit the longest rod inside this cuboid, do you acknowledge it will be from the back top corner to the front bottom corner? So basically, if I say from the top back corner to the front bottom corner. So if I try to join a rod, so that's the longest rod that can fit inside in a cuboid. So it will be something like this. So I hope you are able to visualize this, right? This is how the longest rod will look. Let's say this blue line is the longest rod. Let's say the length of this longest rod is X, suppose. Now, the length of the cuboid is L, the breadth of the cuboid is B, and the height of the cuboid, let's say H. Now, do you acknowledge there is a right triangle wedged inside this cuboid? Now, if I try to join the diagonal of the floor, okay, so I hope you are visualizing this, the diagonal of this floor, this green line that I'm drawing, it's actually the diagonal of the floor. So if I join the diagonal of the floor, there will be a right triangle wedged inside this cuboid like this, right? Now, if I want the diagonal of the floor, that means if I want this green dimension, we acknowledge this, the triangle which is lying on the floor is also a right triangle. And I can apply the Pythagoras theorem. So let's say this dimension is P, suppose. So what will be this P? So if I solve it here, this P will be, I know by Pythagoras theorem, P square is equal to L square plus B square, right? So I'm just talking about a triangle which is lying on the floor. So if to be more precise, let me label it so that you are able to visualize it. Now I'm talking about a triangle A, this point is B and this point is C. So basically the triangle which is lying on the floor, ABC. In this, P is the hypotenuse, so P square is equal to L square plus B square. So from here, I'll get the value of P, which is under root L square plus B square. So I hope everyone knows Pythagoras theorem. We have already discussed this in the first video of this series. Now, so I can write down this P is equal to under root L square plus B square. That's the value of the diagonal of the floor. So this blue, this green thing is what? It's the diagonal of floor. Now, if I take this diagonal of the floor as the base and the height of the room is H and X as hypotenuse, I can again apply the Pythagoras theorem. So if I label it, let's say this point is, let's say D. So basically I can say in triangle ADC, I hope you are able to visualize this, ADC. Again applying the Pythagoras theorem. So this time X square, which is behaving as hypotenuse, will be equal to P square plus H square. Now what is P? I already know the value of P. That is under root L square plus B square whole square, and h square. So this under root and square will cancel off. So this x square will come out to be L square plus B square plus H square, and hence this x will come out to be under root L square plus B square plus H square. And now this is the length of the longest rod that can fit inside in a cuboid. Guys, so this is nothing, this is just the application of Pythagoras theorem twice. So first I applied the Pythagoras theorem on the floor, figure out the diagonal of the floor, taking this diagonal of the floor as the base and the rod as hypotenuse, again applied the Pythagoras theorem. So this is the length of the longest rod, or I can simply say this is nothing but the diagonal of cuboid. So this is the formula for the diagonal of cuboid. And guys, the room is 10 by 12 by 15. So, you can just replace length, breadth, height as 10, 12, and 15. You'll do the calculation, you'll get your answer. But the objective here is to tell you what's the formula and how it is developed. So when I say the longest rod inside the room, which is nothing but the diagonal of the cuboid, which is given to me by under root L square plus B square plus H square. So I hope this process is sorted. Now on the similar grounds, guys, if I ask you another formula, that is maximum distance between any 2 points in a cube. Now I believe you acknowledge the difference between a cube and a cuboid. In a cuboid, I have 3 dimensions, which is LBH. But in a cube, every dimension will be same. So it will be LLL. So guys, the only difference is, if I want it to be a cube, instead of LBH, I'll simply write down LLL. Everything will be same. So it will be L square plus L square plus L square. That will be under root 3L square. L will come out, so root 3L. Now this is what, guys? This is diagonal of cube. Okay, so there's no difference in the thought process. Instead of, as you can see, it's L, B, H, but if you replace with L, B, H with the same dimension, so you apply the same thing, eventually instead of L, B, H, it will come out to be L, 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 right? So I'll get the diagonal of the cube. So this is the diagonal of the cube, that is under root 3L, and this is the diagonal of the cuboid, which is under root L square plus B square plus H square. The understanding is same. The only difference between in a cube and a cuboid, cube, all dimensions are same. That's a perfect Rubik's cube. I believe you have seen Rubik's cube, or I can say a perfect carton. And in a cuboid, the dimensions are different. So I hope you understand both the diagonal formulas: diagonal of a cuboid, diagonal of a cube. Now moving forward, guys, again a very straightforward formula. Two lines are parallel. So you just need to remember, guys, it's a very basic thing. Whenever two lines are parallel, so L1 and L2, two lines are parallel, and whenever a third line cuts two parallel lines, whatever angle, it does not matter. Whenever a third line cuts two parallel lines, all the big angle created will be equal. So this angle is big. All the big angles created will be equal. So this is also big. This is also big. Now you can name them. You can call them corresponding. You can call them vertically opposite. That's your call. But the idea is every big angle is equal, and every small angle created will also be equal. So this angle is small, this angle is also small, this angle is also small, and this angle is also small. So every big is equal to every big, and every small is equal to every small. Very basic idea. So here I can clearly see this angle A is actually a big angle. So angle A will be equal to angle C, equal to angle G, and equal to angle E. All these four angles are big angle. So all of them will be equal. Angle A is equal to angle C is equal to angle G is equal to angle E. All big equal to all big, all small equal to all small. And one additional point, you take any big angle, any big plus any small, it will always be add up and give you 180 degrees. So you take any big plus any small, you always get the sum as supplementary. Supplementary means what? 180 degrees. So I hope this is a very basic formula. Everyone is sorted here. Moving forward, line ABC lie in the same plane. Now if A is perpendicular to B and B is perpendicular to C, then what is the relationship between A and C? Now first of all, you need to understand what do you mean when we say same plane. Same plane means like this whiteboard, that's the same plane, or whatever you draw in your notebook, that's called same plane. Or in simpler words, I can say same surface. So what they say that A is perpendicular to B. So this is the case. A is perpendicular to B. This is A and this is B. And B is again perpendicular to C. So this will be the case. So A is perpendicular to B and B is perpendicular to C. So what is the relationship between A and C? Now do you acknowledge A and C are definitely parallel? So if A is perpendicular to B, B is perpendicular to C, A and C are definitely parallel to each other. So this is only true when they lie in the same plane. So whenever you draw a 2D figure, that means in the same plane, in the same surface, like on the whiteboard, like on your notebooks. So whenever this happens, A perpendicular to B, B perpendicular to C, but A and C are definitely parallel to each other. Very basic formula. Now, again, a very basic formula which you need to be aware of in your SAT, that is an area of a trapezium. Now, what is a trapezium, or what is the difference between a trapezium and a parallelogram? Now, guys, in a parallelogram, opposite sides are equal and opposite sides are parallel. But in a trapezium, only two sides are parallel. So these two sides are parallel. The other two sides are not parallel. So this is, some of you call it trapezoid or some of you call them trapezium, same thing. Now the formula for the area of trapezium is half into sum of parallel sides. So these two sides are parallel, so I'll take the sum of them. AB plus CD, sum of parallel sides, into the distance between them, or you can say the height. So basically the distance between the parallel lines, which is nothing but the height of this trapezium, I can say H. So this is the area of a trapezium, that is half into sum of parallel sides into the distance between them. This height, you can call it, it is nothing but the distance between them. So very basic formula. Now, guys, we already told you the cube. So let me just quickly draw the cube again. So in the cube, it's a perfect dimension. Length, breadth, and height are equal. That's the only difference between a cube and a cuboid. Now, if I take a cube, number of edges, number of faces, number of vertices. So in your room, if you visualize, there are 6 faces, right? So basically, top face, bottom face, and then you have 4 walls on the side. So basically you have 6 faces. And how many vertices? Vertices means the corner points your room have. So you have 8 corners in the room, right? The dots are the corners. So 6 faces, 8 vertices. And how many edges? What do you mean by an edge? The edge means wherever the 2 faces meet, or I can say the line that you need to draw. So 1, 2, 3, 4 line on the top. 1, 2, 3, 4, 4 line on the bottom, and then the 4 lines on side. So basically, how many lines that you need to draw? You need to draw 12 lines. So basically, there are 12 edges. So you should be good in visualizing your cube. So it has 6 faces, 8 vertices, and 12 edges. Moving forward, again a basic formula: distance traveled by a wheel in n revolution. So if it's a wheel, guys, if this wheel revolves one time, complete one revolution, how much distance it will cover? Do you acknowledge it will cover the distance equal to its circumference, or I can say the perimeter? So the distance traveled by wheel in one revolution is given to be by its circumference, which is 2 pi r. But if the wheel revolves n times, it will be n times 2 pi r. So this is the distance traveled by a wheel. In one revolution, it's 2 pi r. If it revolves n times, I'll simply multiply it with n. So the distance traveled by the wheel is given to me by n into 2 pi r, where n represents the number of revolutions. So you need to understand this formula in your recipe. Now, you see, sometimes SAT gives you the formula, but you should not be dependent on your SAT exam to give you the formula. So you should be aware of all these formulas. So I'll give you all these formulas. I'll not go into a lot of depth. I'll just tell you the formula. So you should be aware what is a sphere. Now, what is a sphere, guys? A sphere is a football, right? So it's a football, or you can say any solid ball is a sphere. Now, when I say melting, what I am concerned with, when I say melting, I am concerned with volume. Volume of the sphere is given to me by 4 by 3 pi r cube. That's the volume of a sphere. Now, where r represents the radius of that sphere. Painting. What do we understand when I say painting? Now, painting means surface area. So basically, when I say painting of a sphere, that means you want to paint a football. If you want to paint a football, you are worried about the surface area, which is 4 pi r square. That's the painting of a sphere. Similarly, painting of a cuboid, that means surface area of a cuboid. So if you want to paint your room, so your room has 6 faces. I want to add every face. 2 faces with length into breadth, plus 2 faces with breadth into height, and 2 faces with length into height. So twice into LB plus BH plus LH. That means I paint all the 6 faces, added the area of all the 6 faces. I'll get the surface area of the room, or surface area of the cuboid. Guys, cutting. Remember, cutting also means volume. So cutting means volume, melting also means volume, and painting means surface area. Now, volume of a cuboid, that means, if you want to fill the room or fill this cuboid with water, so we are concerned with volume. The volume is length into breadth into height, that is LBH. You'll get the volume of the cuboid. So let's finish for the cube, and then we'll talk about the cylinder and the cone. Surface area of a cube. Now the difference between a cube and a cuboid is the dimensions are same. So one face will have an area of L square. So 6 faces will have an area of 6L square. So that will be the surface area of a cube. And volume of a cube, the length is L. L into L into L, that will generate L cube. So that will be the volume of a cube, where L represents the length. Now, we talk about the cylinder. Guys, I hope you understand a cylinder. A cylinder is a can, or a cylindrical can. So if I draw a cylindrical can, understand a cylinder has 2 dimensions. One is the radius of the cylinder. This is the radius of the cylinder. And one dimension is the height. So we have the radius and we have the height of the cylinder. This is the height of the cylinder. Now the volume of the cylinder is given to me by pi r square, that is the area of this floor, multiplied with the height of the can will give me the volume of the cylinder, that is pi r square times h. Pi r square h, that will generate the volume of the cylinder. So two dimensions, radius and height. Now the interesting part, which is cone. So guys, I believe everyone understand cone. So cone is an ice cream cone. So if I draw an ice cream cone here, something like this, so it's a, or you can understand it's a conical tent, right? Now cone has three dimensions which you should be aware of. First is the radius. This is the radius of the circle, so that's the radius of the cone. And then you have this perpendicular. This is the height of the cone. This is 90 degree. And then you have one more dimension, which is the slant height, which is this L. So basically this slant height, which is called the length of the slant height. This is L, right? So these are the three dimensions. Now when I say amount of cloth required for a conical tent, this formula, that means we are concerned with the amount of cloth that goes in making this tent. That means the curved surface area, only the curved part. So amount of cloth required for a conical tent is curved surface area of the cone, which is given to me by pi into r into L, where L is the slant height, which is actually given to me by the Pythagoras theorem, which is under root r square plus h square. We already did Pythagoras theorem. So if you want to write down the formula in terms of r and h, in place of L, you can figure out L by using Pythagoras theorem, that is under root r square plus h square, and that will give me the formula for the curved surface area. Now suppose guys, the formula is not mentioned here, but just for the understanding, instead of, apart from this curved part, if I want to do the carpeting on the floor as well, that means I want the cloth to be put on this floor as well. So I'll take the total surface area. That means now the total surface area of this figure will be the curved surface area plus this shaded part, which is a circle. So the area of the circle is pi r square. So eventually the total surface area will become pi r L plus pi r square. This one given here is only the curved surface area, that is pi r L, but you should be aware of, if they ask you to figure out the floor as well, I'll simply add the flat circle, which is pi r square, to the curved surface area, and I'll get the total surface area. Now when I say amount of air inside a conical tent, that means if I want to fill this conical tent with air, that means what I'm concerned with, I'm concerned with the volume of the cone. Now the volume of the cone is given to me by 1 by 3 pi r square h, where r represents the radius of the cone, h represents the height of the cone. So that is 1 by 3 pi r square h. Now guys, there are a lot of applications of this, so you should be aware of all these formulas in your SAT. You cannot ignore any formula. So let's take one question on a cylinder and a cone together. Now see, in this particular question, a right circular cylinder has a radius of 6 units and the height 10 units, is placed upright. If I take a cylinder, something like this, so you have to understand the figure, you have to understand what is actually happening in the question. That's a very good question. So we have a cylinder, the radius of the cylinder is already mentioned, the radius is 6 and the height of the cylinder is already there. Now this height is 10, so I have the radius as well as the height. It is filled by water up to 2/5 of its volume. Okay, An iron cone of radius 3 units and height 4 units is then completely submerged in the cylinder. By how many units does the water level rise? That's a very interesting question, guys. Now, I really don't care whether it's filled 2/5, whether it's filled 1/3, whether it's filled half. Let me decode the idea behind this question. Let's say a cylinder is filled with water till here. Let's say this is the level of the water. Okay. Now, if I submerge a cone, if I submerge, let's say a cone is being submerged, right? So this cone is being submerged in the water. What will happen to the water? If I submerged a cone, do you realize the level of the water will rise? So let's say the water was here, and then I submerged a cone, and after submerging the cone, the water reaches here. Now the idea is the volume of this raised part, that means the volume of this portion, do you acknowledge, will exactly be equal to the cone, because the rise in the water is happening because of the cone. So I can simply put an equation like this: volume of water raised, only I'm only focusing on the water which is raised, that means this portion. Let's say the height of this portion is h, which I need to calculate. So I'm only focusing on the volume of the water raised, and that will exactly be equal to the volume of the cone submerged, because this rise in the water is happening because of this submersion of the cone. So volume of the water raised, that means this blue portion, this blue shaded portion that I'm concerned with, this portion is nothing but cylinder. So the volume will be pi. The radius of the cylinder is already known, pi r square, that is 6 into 6. And the height of this portion, I don't have to take the total height, I just have to take this shaded portion. The height of this shaded portion is h, so pi r square h is equal to volume of the cone, which is 1 by 3 pi r square h. Now the radius of the cone is 3, so 3 into 3, and the height of the cone is 4. So I really don't care. This was useless. I really don't care whether it's 2/5 filled or 1/3 filled. The idea is the volume of the cone will exactly be equal to the volume of the water rise. From here, I can directly figure out this height. Pi gone, 3 gone, 3 into 4, 12. 12, 3 the 36. So basically 3h is equal to 1. And the rise in the height actually comes out to be 1 by 3 unit. That is option number A. So you should be aware of these formulas. You should know what is happening with the question and just put the formulas properly, get it done. So you have to remember all these formulas. So guys, I finished these 6 videos on geometry series covering all the basic concepts that you need to know for your SAT. So I hope guys you enjoyed this video. So that's all with geometry. So we have finished the entire series of geometry, and have a good day guys. Bye bye.